All right. Next thing we're going to talk about is partial pressures and the mole fraction. Okay. The mole fraction is not something that we use very extensively, but it's something I want you to see and understand where it came from. Okay. And so it comes from the fact that because each member of a gas mixture is independent of the others, we can relate the amount of gas given in a mixture to its partial pressures. Excuse me. And so for gases that are behaving ideally, we can say that the pressure 1 divided by the pressure total is going to equal, okay, all right, I'm going to write it up here. Sorry, that's kind of small. So pressure 1 divided by P total is going to equal N1 times RT divided by V. That too is going to be N total times RT divided by V, which really is going to equal N1 total, because all these other things are N1 divided by N total. And so really, we kind of just take this middle lump out, and we just kind of say that the pressure 1 divided by the total pressure is going to equal to N1 divided by the N total, because all of this stuff is essentially going to be a constant. The RT divided by V, RT divided by V, all that drops out of the equation, and it leaves us a more useful tool that we can use to get that done. Okay, now the mole fraction is just the ratio of the number of moles, of that part to the total number of moles in the mixture. Now this leads us to the next explanation, or the next mathematical expression of this, and this is going to be right here. It's supposed to be this blank right here, so it's up here. Okay, and so what we're going to look at is, this is a funny looking X, is called chi. That is the Greek letter chi 1, which this is the mole fraction. Okay, so the mole fraction is equal to the Greek letter chi, and so that is equal to the moles of whatever item number 1 is, divided by the total number of moles. And so that's really just equal to N1 divided by N total. Okay, so that's where that goes. Now we can combine this equation and this equation, and we can combine that to give us a new equation to yield what this bottom line here should be. And so that's going to go away. I guess I'll write it. You know what? Hang on. I'm going to pause, erase, and move this up a little bit. So give me a second. All right. So I'm going to move that up a little bit, and we're going to write down here to show what that looks like. Sorry, I missed that. And so when we combine those together, what we end up with is that pressure of 1, so P1 equals the mole fraction, the moles of 1 divided by the moles total, which parentheses P total, which is going to equal our mole fraction, so chi squared of 1, or chi of 1, times the pressure total. Now again, we're not going to use this a whole heck of a lot, but it is something that we're going to see, and I want to make sure that you have seen it and know what it looks like. I don't have any examples built into this one. Sorry. If we need to, we can do some in class. So there we go.